This section is about the properties of materials. Understanding the structure of atoms and how they bond together will help you understand the properties of materials. As you watch the next clips, see how the properties of materials are related to their atomic structure.
Well, this gold leaf here might look pretty thin. You can almost see through it, but it's actually 250 atoms thick. We need to look a little closer. Magnified by an electron microscope, these are individual atoms of gold. To help understand these images, scientists use models to represent the relationships between the atoms, the actual structure of the material. Properties. A battery here connected to a light bulb. If I close the circuit with this gold bar, if gold conducts electricity, then the bulb should light up. Yeah! By being able to look at gold at an atomic level, we can see that it should be a very good conductor of electricity. Moving around between all atoms are electrons, and there are very many of these freely roaming from atom to atom. When you apply voltage from a battery, this random movement becomes a general drift, and that's an electrical current. This is the surface of diamond. Magnified 100 million times, we can see the individual carbon atoms that make up its very structure. Again, looking at a model of these atoms can help us to understand something of the properties of this material. With diamond, we see that the electrons are tightly bound between the atoms. These bonds are all extremely tough and are very difficult to break because the atoms are being held so firmly together. That's why diamonds are so hard. Unlike gold and other metals, diamond doesn't have many freely roaming electrons to carry the current. So it doesn't allow electricity to flow. It's called an insulator. Here, the same carbon atoms are now arranged in layers. Not all the bonds between the atoms are strong. Those between the layers are in fact very weak, so some of the electrons are freely moving around. This almost looks like a different material. It is. This is graphite. And of course there's graphite in your pencils as well. And the movement of electrons means that graphite is a conductor of electricity. If we show this with my friendly battery, if we connect the pencil through the light bulb to the battery, light bulb lights up. But the layers of atoms in graphite are not held together very strongly, and it's the fact that these layers can slide over one another easily means that graphite's a good lubricant. We've now seen that carbon atoms can arrange themselves in two different ways, making two materials with totally different properties. If we look at the atoms of carbon fibre, we can see that they have the same structure as in graphite. But in a fibre, they've twisted into a spiral shape like a rope to make it stronger. Many thousands of these are then bundled together. When resin is added, it joins and reinforces the fibres into one tremendously strong material.
So we saw that gold is a good conductor of electricity because free-roaming electrons between the atoms flow as an electric current. Gold is also flexible, ductile and malleable because the layered structure allows its atoms to slide over each other. The clip also looked at diamond and graphite. These are the two most commonly known forms, known as allotropes, of carbon. They have very different properties because of their different atomic structures. Diamond is very hard. Its electrons are packed tightly between atoms, forming very strong bonds. Diamond is an electrical insulator. That's because there are no free-roaming electrons to flow as current. Diamond is also an excellent thermal conductor. Graphite is soft. Its electrons are not packed tightly between atoms and do not form very strong bonds. Graphite is an electrical conductor because free-roaming electrons between the layers of graphite can flow as a current. Graphite is also a good lubricant because the layers in its structure can slide over each other. We also saw how materials can be modified and combined to create composite materials. Carbon fibres are strong but flexible. Resin is stiff but breaks easily. Combining the two materials creates a composite material that is both strong and stiff. That's the end of the whole section on classifying materials.